And so it is time for us to move beyond our solar system. We're going to start with considering the size of the space just beyond our solar system. Already we know from our discussion last time that the Oort cloud, the trillion comets that exist, are about a light year from one side of that spherical cloud to the other. A light year is big enough. That's 6 trillion miles. Okay. Now let's go beyond that. Let's consider for a moment, just take this journey with me. Consider for a moment the distance from our sun to our closest neighbor, Proxima Centauri. It's like 3.5 or 4 light years away, depending on how you measure it. Okay. So it's 3 to 4 light years away. Now, if you were to walk that distance or drive in your car on the interstate that distance, how long would it take? Would you be able to do it in one lifetime? Would you be able to do it in 10,000 lifetimes? That's where we begin chapter 2, Beyond. All right. So we're starting with page 34 in your book, and 34 is going to be like 34 and 35 are going to be you doing some simple calculations. Follow the example in chapter check number 2, right? And I'll go over that here together with you. Let's start. So, and a good mental exercise when we think about the stars beyond to begin our discussion of distances to the nearest stars, our closest neighbors, if you will. It helps to think about the constellations that we know, something familiar. So let's start there. Take a look in this picture right here. I bet if you looked long enough, you could find Orion. I bet if you looked a little bit longer, you could find Pisces and maybe Draco. I bet you could find Andromeda. I mean, if you really familiarized yourself with what the constellations look like, you would know that over here is Orion. There's the 3 belt stars. It's above where the man's pointing in the night sky. It's above his shoulder. And then over on the other side, here, this kind of V-looking thing with a kind of a circle at the end, that's Pisces. Okay. Below that, other constellations that eventually you get familiar with if you study this long enough. So considering the constellations, let's start with the stars that are closest to us, our closest neighbor, and do a few calculations just to get an idea how far away that truly is. Here we go. All right. So page 34, you leave it blank. You can add a sketch to it if you wish. I'm going to move my little picture here. Come on, little picture. All right. So we're down over there, page 35. And it is time to think bigger, a whole lot bigger. So I want you to write down some numbers. You got to copy all these words, make them all fit on page 35 to do it correctly, because they're at the very bottom. Now, you're starting to realize how big just our area of space is. So you walk to school. If you walk to school or drive, whatever, put down that number of miles from your house to the school. 1 mile, 2 mile, however long it is. Some of you have a long walk to school. Hats off to you. That's not easy to do that. So then in the next blank, what is the longest hike you've ever taken in your life? How far did you walk? To where? I hiked to Bridal Veil Falls, or I hiked through one of the national parks. I hiked through Zion or Bryce or something like that. How many miles did you do? You hiked for 3 miles or 6 miles, or somebody's really gung-ho. I did a week-long trip and we did 40 miles, or whatever it is you did. Fill in that blank there, that number. Doesn't matter what it is. Small number, big number, doesn't matter. Put that amount down. Now, think about the farthest car trip you have ever taken in your life. How far away did you go? Use Google Maps maybe to map out how far it is to that destination, and you can see in Google Maps how long of a trip that is. Maybe it's 600 miles, maybe it's 2,000 miles. Whatever your Sorry, my nose is itchy. Whatever your longest car trip, write it down there. All right. Letter A. If I redo my longest walk every day and live for 100 years. So again, you're taking your longest walk you did, the one over there, okay, over there. You write that number down again. I hiked for 6 miles. I hiked for 3 miles. Doesn't matter. Sorry, friends. My nose is running here. I get an eye injury and my nose is running because of it. Okay, so apologize. So there we are. You've written down that. Now multiply that number, however many miles that is, times 365. So you're doing it daily, and you're doing it for a 100-year lifetime. How many miles would you walk in a lifetime if you did that amount every day? No, it's not reasonable, but it gives us an idea. And you got a total number of miles. It'll probably be in the thousands or tens of thousands of miles. Okay. Then, letter B. Your longest trip. Let's say you make that trip 5 times a year for a whole lifetime. So put that number of miles times 5 per year and times 100 for your whole lifetime, and now you have a different number of miles, probably a pretty big number. All right. Now let's consider distances. 1 light year is about 5.9 trillion miles. The nearest star is 4.3 light years away. That's 25-ish trillion miles away. Take that number, 2, 4, 7, 8, 0, 0, 0, 0, 0, 0, 0, 0, 0, all those zeros. Divide it by your bigger number, A or B. How many miles you can go in one lifetime. And then you get the total number of lifetimes of hiking or driving, whichever one's bigger, right? How many lifetimes would it take you to get from here to Proxima Centauri if that's how you were traveling, in your car or hiking, that number of miles per day? Okay. The number of lifetimes of travel you get, that's the punchline in thinking big, really big. Okay. So please do that. All right. And if you use any sources, you don't have to. You can say sources, Google Maps to figure out my distance. Sources, my mom, because she knew how far a big hike was. So credit any sources you may need to on the bottom of page 35. Okay. That's how you build 35. And that number of lifetimes of travel you get may surprise you. Okay. So that's page 35. I'm going to move my little picture back over where it was. It's time for us to consider the stars nearby. Okay, so we already talked about those. So I had you think of constellations a moment ago. Now let's start working on the next few pages of your book. We're talking 36 and 37, and in this lesson today we'll also cover 38 and 39. So we're going to get through 4 more pages of your book. The first couple are about constellations. The second ones are about nebulae, like these big clouds in space. Here we go. All right. First off, constellations are not just the stars, okay, any more than a city is just the buildings, right? If you look at a city, it's not just the buildings and it's the parks and it's the streets and it's the neighborhoods and it's sidewalks and everything. It's all that, not just the buildings. So when you think of a constellation, I strongly encourage you to see it as a chunk of space, not just a few bright dots. Those dots, they form a picture, like the Big Dipper, right? That's called an asterism. So see more than just the dots of stars in the sky. See the space around it, that block of sky. And in the 1920s, almost 100 years ago, the IAU looked at this and made a map of all the spaces in the sky, and they marked off 88 constellations in the sky. Okay? These are addresses, my friends. Let's take a look what I mean by these being addresses. Constellations, think of it like one constellation, think of it like a city. Okay? And inside the city, you've got locations within that city. Okay? Not just a few stars that are bright, but lots of things inside a city. You could stand on a street corner in a city, you could stand inside a park, you could be inside a building, you could be at a gas station. You're at a lot of different places still in that city. Here we go. Take a look. Cygnus, okay? This picture here of the night sky, it shows the constellation of the Swan. That's what Cygnus is. Its tail feathers are up high. That's Deneb, the tail feathers. And going down past Eta and to this pointer star in the front, that's the long neck and the head of this constellation, the Swan. And then the two stars on the side are his wings, spread out, and he's flying, like downwards. So the stars make the picture of the Swan, but this whole block of space is more than just those 5 stars. Okay. There was a mystery object they found in Cygnus. They didn't know what it was. It was just producing some really strange numbers. This is 1970s, 1980s. They looked at this mystery object inside that block of space. And it's a mystery, so it's an X. It was the first mystery object in the Swan constellation. So they gave it a number 1. Cygnus, X1. It wasn't until much later, and analyzing what they were looking at, that they found at that address in the sky is the first confirmed black hole in space. The first one we knew they might exist, and now they found one for the first time. So in the Swan, at a location X1. So that's the address of the first black hole, Cygnus X1. Boom, it's an address. All right, let's look at another one. Look at this picture down further below. We have Andromeda, the lady in the sky who bragged on her daughter being so beautiful, more beautiful than the goddess Athena. And the gods didn't like this, so they stuck her upside down in the sky. And so all the blood rushing to her head, and she's punished forever, hanging upside down in the stars. That's Andromeda, the lady in the stars. Within those major stars, again, within that whole block of space, they found a smudge that was thought to be just some cloud, a little smudge of light. They're like, oh, that's just another cloud in space. And then along comes a guy named Edwin Hubble, and he looks and realizes, wait a second, that's not a smudge in space. That is an entire galaxy. And somebody else is like, you think you found another galaxy? Where is it? And he gave them the address, the constellation Andromeda. So it's a galaxy in Andromeda, and now we call it the Andromeda Galaxy. Boom, it's the galaxy next door. Now it has a number, it has a house number within its city, Andromeda, NGC 224. That's just the number they gave it. They assigned, or Messier 37, or M37. No, sorry, 31. So it's got numbers, just like your house has numbers, just like a business address has numbers. But what is it? City in the sky? It's block of space, Andromeda. That's what I mean, my friends. When I say a constellation, it's like a city. Okay? It's a block of space, not just a few bright stars. Okay? If you can lock that in your brain, that the Big Dipper is more than just a cup-looking thing in the sky. It's a whole block of space around the cup in the sky. All right. There we go, constellations. Now, let's take a look at nebulae. Now we're moving on to the next couple pages, and then I'll show you what I want you to build in your book. Clouds in space. Again, this guy Hubble, looking at the night sky, figuring things out. He saw, through a very, very good telescope, more things than anyone had ever seen, and he really had a good critical thinking mind. In this picture, you see stars, and you see smudges of light that could be clouds, lots of clouds, but you also see others that are whole galaxies. It's the clouds I want you to focus on for now. Check it out. All right, those clouds in space. My friends who speak Spanish, right? If you know the Spanish word for clouds, nube or nubes, right? The clouds in space, nubes. The Italian word is nebbia. So nubes, nebbia, nebula. Where do you think the word came from? Clouds in space is the word for clouds in all the Latin languages, right? The Romance languages are Italian and Spanish and French, okay? So there you go. There's your word for clouds in space. At first, these clouds at the beginning of the young universe, they were all hydrogen. Now they're enriched with other elements as well. But at first, just hydrogen. And that's where the first stars were born. That's where stars are still born to this day. Clouds on Earth don't make stars, they make rain or sleet or snow, right? Hail even, okay? But clouds in space create stars. Big clouds, heavy, dense clouds make big, bright stars. Blue giants, right? Red supergiants, hypergiants even. Average-sized clouds produce stars like our sun. There we go. Okay, little clouds produce little red dwarfs, and they're small, kind of dim stars, but they're still stars. They're bigger than planets. They're still stars. All right, so nebulas in space are the places where the stars are born. Let's take another look at actually some more information here. So at first, I said it was all hydrogen. Over time, as stars would annihilate themselves and go supernova, or two stars would orbit each other, combine, and explode, those events helped turn the hydrogen of the first clouds into heavier and heavier elements. Now, it wasn't just hydrogen, it was hydrogen and helium. And eventually, in a giant star, we can have elements being made like lithium and carbon and even oxygen. Oh my, that's cool. But when you get up to a heavier element like iron in steel, like iron in a car or train tracks, or the iron in your bloodstream, right? The iron is kind of the limit of what a normal star, red giant star, or any giant star like that can produce. The belief, the strong scientific reasoned belief, is that the elements heavier than iron can only be made by some catastrophic event that forces heavier elements to be made. Elements like gold or silver or platinum, the radioactive elements, uranium, plutonium, radium, polonium, right? All those heavier elements beyond iron can only exist when they're created in supernova explosions in space. Or, here's the latest theory, it's not on this slide, or if two neutron stars orbiting each other eventually come together and occupy the same space. If you crash two heavy objects like that together, it's going to create heavier and heavier elements for the universe. And these clouds in space are now capable of not just making more stars, but planets and asteroids and comets, liquid water, right, and frozen water, gas giants, rocky planets, dwarf planets. Every solid object you can think of could not exist except for things like supernovae explosions enriched those clouds, and now we have our Earth. So cool. All right. So that's how each generation of stars enriches the universe. Let's talk about stars that are born in the same place. Check out this group of stars, my friends. This is Pleiades. It's not a constellation in the sky. It's just a cluster of stars that happen to be really close together at the moment. They are drifting away right now from the cloud, the nebula, where they were born. They were all born. All of these beautiful blue giant stars, the seven sisters they're called. Okay? All of these beautiful blue giant stars were born in the same stellar nursery. And they drifted out of the cloud where they were born. And eventually they'll spread apart and drift apart on their own as time and their movement carry them away. But they all came from the same place. We know this because chemically they're all pretty much identical. They all came from the same source. They all came from the same cloud. They're all roughly the same intensity. They're all the same star type, this blue giant type. So nurseries can produce whole litters of stars, not just one at a time, but in this case, 7 or 10 or 15. How about a nebula big enough to produce 1,000 stars in a short amount of time? That's an active part of the galaxy producing lots of stars. Maybe lots of planets, right? Who knows what's out there? But they're always being born from these clouds, these nebulae in space. All right. So we've talked about the stars. Now I'm going to walk you through how you're going to build these pages. 34 and 35 we talked about a moment ago. Make sure page 35 has all these blanks, all these numbers. Don't just be like, oh, I'm at the bottom of the page and I ran out of space, forget the rest. Put it on the other side if you need to. Finish your calculations if you want full credit for page 35. All right, 36 and 37, you're going to pick one constellation. Does not matter which one you choose. Put it on page 36. Sketch Orion or the Big Dipper or your constellation, right? If you were born in June, you're a Gemini. Is that right? Yeah, Gemini. Draw Gemini. Draw the constellation Gemini. I'm a Pisces. I would draw a Pisces. I'd look it up and I'd be like, oh, okay, that's what it looks like, and put it in my book like that, and I'd label it Pisces at the top. When you build your constellation in this space right here, make sure you label the stars that have names. So when you're looking at your picture, be like, oh, look, Deneb and Arcturus and so forth. Write down the names of those stars. Put them in there. Oh, wow, I'm doing Orion. I better label Betelgeuse. That's one of the most prominent stars in Orion. Betelgeuse. Put the label of that star in there. Okay, so that's page 36, your picture of a constellation. 37, start with these two paragraph headers over there, the one on the top and the one on the bottom, and you have some gaps in between to fill in your own interpretations, your own research, what you discover about constellations. First one, tell a story about a constellation. For me, I don't know why Pisces got named Pisces. It's the fishes, right? Those two fishes in the sky. I would research it and write the story about Pisces. You pick your own and write a story about any constellation. It does not have to be the one you did a picture of, but it could be. And then on the bottom, constellations are more than just the stars. They act as addresses in the sky, a way of finding things, right? How many constellations did the IAU establish? If you have to wind this video back and look it up again, be my guest, or look it up, right? Put down the number of constellations, and that's how they locate things in the universe, in this night sky. And to find anything that one scientist is like, whoa, check that out. Another one's like, okay, where is it? It's at this address in the sky. Boom, there you go. Okay. Fill your page 37 with interesting information about the constellations. Don't skimp. Make it a good page. And let's move on to 38 and 39, and we'll be done with our lesson today. 38, stellar nurseries. Okay. All right. These are the places where the stars are born. Okay. I picked the pillars of creation for this particular picture above, right here above where I'm talking to you. You don't have to pick the pillars of creation. Pick one of your own, any nebula. Pick the God's Eye Nebula, pick the Cat Eye Nebula, pick the Helix Nebula, pick the antennae, or no, that's a galaxies. Pick any nebula, a cloud in space, sketch it, put its name. Make sure you put the name. A lot of them I can recognize, some of them I can't. Make sure you put the name. Give it its name, okay? All right. And then on page 39, on this side now. What is a nebula? My researched answer is, don't just put it's a cloud in space. That's one sentence. You got to fill this page with information about the clouds in space. For example, what's in blue here? Please don't rewrite all the blue questions. They're just meant to give you things you could write about if you wish. So as you're writing in this space on page 39, consider the gases, what forms in nebulas, how do they look to the naked eye, how would they look through a telescope, how big can they be, and how do the nebulas themselves form? Where did they come from? How do they form? How do they look the way they are? Okay, so it's up to you. Fill this page 39 with information about those clouds in space. Make sure you use your sources, include your sources on page 37 and 39. Okay, so I believe that wraps up our conversation today. I'd like to thank you for tuning in and watching this. Build those pages as you start in chapter 2. Make sure you've turned in your pictures of your work from all of chapter 1 at this point. So the first half of chapter 1, chapter check 1A, goes out to page 17. The second half goes to page 31. Make sure you have those finished, right? Get those done. Take your photographs with your cell phone, upload them into Canvas, okay? You can open the assignments now and just put them directly into Canvas. Or you can attach them to an email, send them to me that way, or a Canvas message. It all works. Other students have put them into a Google document and invited me to edit, knowing I'm just going to look at it and grade it. Very clever. That works too. Okay. So, my friends, get these things done. We have until October 16th for the end of first quarter. Make sure that date does not sneak up on you. Get your things done. You have one more assignment after chapter 1 is finished. Even though you're working in chapter 2 now, you have one more assignment to do that'll be graded for first quarter, and I'll talk about that in my next video. Okay, you're going to build a poster on the life cycle of the stars from where they were born in a nebula to the time they die as a little cold white dwarf, or the big ones, how they annihilate themselves and crush themselves out of existence as a black hole. Okay, and everything in between. All right, thanks for watching. Let me know if you have questions. Get to work, make some amazing things happen, and keep looking up.